Been meaning to do this for a little while because we're still having some trouble writing vectors. First of all, I'm going to push the beer bottle. Now, while I'm doing that, the free body diagram of the beer bottle, which I'm going to treat as a particle, looks something like this. There's the force that I apply when I push, and we'll call that F push, unsurprisingly. There is the gravitational force. There is a frictional force. And there is the normal force. So what we'd like to do is write that free body diagram down mathematically. To do that, we're going to use I hat and j hat vectors. So we need to have some axes defined, or the I hats and the j hats don't make any sense. There's the y-axis. There's the x-axis, for the sake of argument. And it can't hurt to mark nearby our diagram a reminder of which way we were accelerating. Okay, so as we know very well, the sum of the forces, which in vector language is written like this, four forces, 1, 2, 3, 4 forces equals mass times acceleration. That's all the forces in each of their directions, as indicated by these arrows, but when I write them in terms of j hat and I hat components, look what happens to the arrows. The gravitational force is downwards, so that's a force of magnitude Fg in the minus j hat direction. Notice there's no arrow over the Fg. This is now the magnitude, and the minus j hat gives us the direction. The normal force has a magnitude Fn, and that's in plus j hat. The friction force has a magnitude fric, and that's in the I hat direction, or my apologies, the positive I hat direction. And my push force, well, that's the one that's got two components. So if we have this angle here as theta, and the push force is F push cos theta in the minus I hat direction, and F push sine theta in the minus j hat direction. And all of that is equal to mass and acceleration, and that was in minus I hat. And there's the whole expression. That is a mathematical expression for this free body diagram. And you ought to be able to check that all the pieces on your free body diagram appear in your mathematical expression. Notice each time that each vector has a magnitude and a direction. I don't write that's a vector with two directions here and here, so that would be wrong.